Good morning, students. Today we'll discuss about axiomatic approach to probability. This approach based on certain axioms. Now, what is axiom? In class 9th we have discussed. We studied about axioms. Axioms are nothing, some basic facts which are accepted without any proof. Now, if you say twice of equals are equal, if two numbers are equal, then the twice must be equal. We cannot prove this. We can accept only. So axioms are some basic facts which are accepted without any proof. So this approach is based on axioms. Okay? For any sample space S, for any random experiment, the probability is considered as a function. Okay? What is probability? Probability is a function which assigns non-negative real number P of A, which assigns non-negative real number P of A to every event A, and this non-negative real number P of A is called probability. Okay? Now, if we consider S is one sample space, omega 1, omega 2, omega 3 to omega n. These are sample points for any random experiment. Okay? Then the function P, which assigns non-negative real number P of A to every event A, which is subset of S. Then it's said to be probability function if these axioms hold. If this axiom is satisfied, then we say P is probability function. If probability of omega I is from 0 to 1, its value should be from 0 to 1. It cannot be less than 0, cannot be more than 1. Okay? If this happens, then it can be a probability function. Then probability of S is 1, means probability of omega 1 plus omega 2 plus probability of omega 3 and so on up to probability of omega n is 1. Okay? If this happens, these are all elementary events for samples omega 1, omega 2, omega 3, simple event. Simple event means only one element is in the sample point. Only one sample point is there. So these are the elementary events of this. So their sum is equal to 1. Then for any event A, the subset of S, we have probability of A is equal to probability of omega I, where this omega I belongs to A. If this axioms hold, then we say P is probability function. Okay? Suppose we toss a coin. Then this is sample space for tossing coin. Now we assign a number, suppose 1 by 2 for elementary events H and T. Then in this case P is a function, probability function or not, we will check. So this is P of H, P of T. If you consider. Now, first thing, both are more than 0, less than 1. The first axiom hold. Second axiom, if we add this both numbers, then we get 1. Okay? So what we can say, P of H is half, P of T is half, and this is a function, probability function. This assignment is valid. If we assign one number for H 1 by 4 and for T 3 by 4, okay, then again both are more than 0, less than 1, then the sum 1 by 4 plus 3 by 4 is 1. So this is also one valid assignment, means probability of H is 1 by 4, probability of T is 3 by 4 in this case. ठीक है, this can be happen है ना. There are some biased coin, unbiased coin. So in biased coin, probability of getting hat can be more than less than probability of getting tail. We'll see later on this. So one given assignment is valid or not. You have to check this value of p of omega I should be from 0 to 1, between 0 and 1, either 0 or more than 0, 1 or less than 1, and their sum of all the elementary events should be 1. ठीक है, this is our axiomatic approach. Can note down this. Now here we have given some assignments of probabilities for outcomes of sample space S, and your outcomes are omega 1 to omega 7. ठीक है, these are the probabilities are given. So these assignments are, which assignment is valid, you have to check. ठीक है, sorry. So first, for this first assignment, what you see, each value p of omega I should be like this, means its value can should be 0 or more than 0, less than 1 or equal to 1. So here each value is positive and less than 1. ठीक है, so first axiom hold, each p of omega is non-negative and less than 1. ठीक है, then second thing, what should be there, sum of these probabilities p of s, if we add them, 0.1 plus 0.01 plus 0.05 plus 0.03 plus 0.01 plus 0.02 plus 0.06, so its value should be 1. So if we add 0.01, 0.05, 0.03, 0.01, 5, 3, 8 plus 9 and 10, so means 0.1, 0.1, 0.2, 0.2, 0.4 and 0.6 means 1. So this sum is 1. So each value p of omega I is non-negative and less than 1, and their sum is 1. So this assignment is valid assignment. This can happen. ठीक है, now for second, again each value is non-negative and less than 1. Now if we add this 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.7, 0.6 is 1.3. These two are giving some more than 1. So if we add all this, it will be more than 1 only. So it is not valid because sum is not 1. ठीक है, then here in these two cases it is less than 0, negative value. So this p of omega I for 1 and 5 values are negative. So first exam does not hold. So it is invalid assignment. ठीक है, each value should be non-negative and less than 1, and the sum should be 1. Then only assignment can be valid. Here all the values are positive. ठीक है, then it is 1 by 14, 2 by 14, 3 by 14, all are less than 1 only. But here 15 by 14 is not less than 1, it is more than 1. So if you add all this, again sum will be more than 1 only. So it is also invalid assignment. So if some assignments are given, how to check they are valid or not? See each value is non-negative and less than 1 and add them. If their sum is exactly 1, then the given assignment is valid only, otherwise invalid. ठीक है.